And there will be some more forms, but we will start with line parallel to x-axis. A straight line parallel to x-axis can be described as, graphically, it is a line parallel to x-axis. This is x-axis. If it is at a distance, say B or say C, some distance represented here, this line can be written as, because its y coordinate is fixed, which is of length B. This is y intercept, but this line has no fixed x intercept. So in such case, y equal to B only describes the line. Second form, the straight line parallel to y-axis. Same is the case, but orientation of the line will be reversed. This is y-axis. Now the line is parallel to y-axis like this or like this, to the left or to the right. If it is to the right of this at a distance a, everywhere the distance will be a, then this line will be having its x-intercept, which is fixed of length a, and there is no fixed length of y-intercept. In such case, we write the equation of line as x is equal to that length of x-intercept. The third form, the line passing through origin, maybe like this way or say this way, having another positive inclination, say phi. In such cases, only slope of the line is executed, because there is no intercept on x-axis, no intercept on y-axis, or we can say the length of intercept on x and y-axis is 0 due to this origin. Then the line can be described only by y is equal to mx, where m is the slope of line that can be obtained using tangent theta, already told you in starting of the lesson. Let us take another form of the line. This line, the straight line, having its slope as m and its y-intercept is known to you, say of length c. M is the slope and c being the y-intercept of the line. In this case, say graphically this line will be making y-intercept, this length y-intercept, which is c, assumed as c, small c, and say due to this theta, value of tan theta may be represented as m. If we know m and c, we can write the equation of line in the form y is equal to mx plus c. So describing this form as slope intercept form of the line. Coming to next form of straight line, which is called the slope point form. In short, it may be called one point form, because one point on the line will be known to you. Say graphically representing, I am writing P, x1, y1, P, any point on this line which is like this. Slope point form, so we must know the inclination theta, getting m is equal to tangent theta will give you the slope. Now I got the slope and the point on the line, so this line may be written in slope point form as y minus y1 is equal to m bracket x minus x1. This will be called slope point form or one point form of the line. After this, another form of straight line which is 2-point form. Straight away saying 2-point form, as the name suggests, the line with 2 points given on it, say P and Q. And in previous form I write P x1 y1, the single point on the line. Now I am writing P x1 y1 and Q x2 y2, another point on this line. So P and Q being the 2 points with given coordinates on the line, the 2-point form will be represented as y minus y1 is equal to y2 minus y1 or x2 minus x1 bracket x minus x1. Here x1 y1 being the coordinates of first point, x2 y2 being the coordinates of second point, which have been used over here. xy will remain as it is because the equation will involve two variables x and y. We have more forms of straight line, but this time we are going to discuss some examples based on only these forms which have been discussed till now. So first of all, we studied y equal to b, the line parallel to x-axis, x equal to a, line parallel to y-axis, y is equal to mx, line passing through origin with slope m, y is equal to mx plus c, line having slope m and y-intercept as c. 1-point form, y minus y1 is equal to m into x minus x1. Another form, 2-point form, y minus y1 is equal to slope into x minus x1, where slope m was replaced by y2 minus y1 over x2 minus x1. This was 2-point form. Now I will give example accordingly. As we have discussed these forms, I will take examples accordingly. First of all, say draw a line, write the equation of line having its distance from x-axis as 2 units, positive 2 units. So this is x-axis, 2 unit being the distance. So this line will be y equal to 2 straight away. The intercept, y-intercept will become constant. So y is equal to 2 is the only form. Another example with negative x-intercept. This is x-axis. I am taking x-intercept is equal to minus 3. Length of the intercept is 3, but it is passing through minus 3 to the left of x-axis. So the equation will be x is equal to minus 3. I'm sorry, I have used the term y line parallel to x-axis as y equal to 2 and line parallel to y-axis with negative intercept as x is equal to minus 3. This line being parallel to y-axis, not x-axis. I'm sorry for that. And now the third, y is equal to mx. See how this equation can be used when you are given slope only and simultaneously you are given that line is passing through x-axis. For example, this line passes through origin. This is having 0 x intercept, this is having 0 y intercept, no x and y intercept, so that line can be written as y is equal to slope into x. If I say the slope is 1 unit, the value of tan theta is 1 unit, then it is 1x. If it is say 2 unit, then it will be 2x. So whenever you come across such line, ax plus b equal to 0, a1x plus b1y equal to 0, such lines clearly target origin, they always pass through origin. Taking an example of fourth form, which is slope intercept form, I say find the equation of line, this line having slope m, this tan theta, which is m, and having the length of this intercept, this is y-intercept, this y-intercept is say 2 units because it is on above x-axis, this is positive, hence I will write the equation with m is equal to 3x plus 2. If m is 3, y-intercept is 2, then the equation of the line will be y is equal to 3x plus 2. No doubt, we can change these lines, these equations to some different styles, say 3x minus y equal to minus 2, 3x minus y plus 2 equal to 0, so many forms, ax plus by plus c equal to 0. This is general equation of the line. So we can always get these all forms to general form, taking ax then by then constant equal to 0 to the right. An example of this form, this is 1 point form. I remind you, y minus y1 is equal to m into x minus x1, where x1 y1 is the point through which line is passing and m being the slope of that line. The question is, write the equation of line with slope say 3 units and point through which it is passing is 1 and minus 2, say t point. I will use this equation straight away, saying this is x1, this is y1 and slope is given. Just to substitute the values y minus minus 2, it will make it positive, then slope is 3 and x minus x1 is 1 over here. Simplifying the equation, we will get 3x minus 3 to the right, then 3x minus y is equal to 5, or 3x minus y minus 5 is equal to 0. The last example of 2-point form, I have taken 2-point form y minus y1 is equal to y2 minus y1 over x2 minus x1 into this factor x minus x1. I have placed m over here. You can directly put y2 and y1, x2 and x1 over here, or you will equate the slope alongside and then put the value of m to this form. This is 2-point form. If I put y2 minus y1 over x2 minus x1. Write the equation of line, this line PQ, for which the 2 points are 3, 2 and 1, say 1, 1. Alright, 1, 1 and 3, 2 are the 2 points, this being x1, y1, this being x2, y2, because I have to substitute all over here. Y minus y1 is 2, y2 minus y1. Now I take 1 minus 2 over x2 minus x1. This is 1 minus 3 into x minus x1. X minus x1 will be x minus 3. So simplifying this, y minus 2 is equal to minus 1 by minus 2, x minus 3. I get y minus 2 is to 2 is equal to x minus 3, and then x minus 2y is equal to minus 4 plus 3, which is x minus 2y plus 1 is equal to 0. So I have taken one example of each kind of the form that we have discussed in this session. Some more forms are there which are going to come, and I will be giving example for those forms as well. But till then, you just try some examples of this, and if you have any doubt, you can put your suggestion.